Hey, welcome back to Math with Patrick. It's April 4th, and we're solving the 94th problem from this Daily Epsilon calendar. And as always, the answer is today's date, so we need to show why x should be 4 today. So taking it as is, I just have some equation where when I add two numbers, I get 4. And studying it a bit further, I could imagine plugging in different values for x. So maybe x could be like, well, of course, we both know the answer is 4. But let's pretend I plug in like a really big number, like 100. Already this number is going to be 50. And then this number is going to be kind of small, like 8 over 100 is kind of close to 0. And so it looks like plugging in large values produces also pretty large values. It's nowhere near this 4 that I want. So I'm looking at plugging in even like an 8 here, makes a 4 already. And then 8 over 8 would be a 1. So plugging in 8 looks like it's just too big. And if I try plugging in negative numbers, x totally could be a negative number. Why not? Maybe if I try like a negative 8, well, I'm getting a negative 4 plus a negative 1, and I'm not getting the positive value that I want for today. And looks like if I plug in negative numbers, I'm nowhere near. If I plug in large numbers, 8 or anything over, I'm nowhere near 4. Well, actually, plugging in 8 was kind of close because I got 5. So maybe let's have that be a jumping off point. So I could just try, plug in some numbers. What happens if I plug in an 8? Here, I'll fill out my table. I'll write the expression as is on the left side. And this gave me like a 4 plus a 1, which is a 5. Now, I don't really want to plug in odd numbers just because dividing that by 2 and then doing like 8 divided by an odd number, that's really not going to be that helpful. And I feel like I'm going to get weird, wacky decimal numbers. So the next reasonable number in my mind to plug in would be a 6. If we do 6 divided by 2, we get a 3 here. And then 8/6 does reduce to 4/3. But then this is some kind of fraction number. I mean, it is 4 1/3, so why not write it as such? But this is not the same as 4. So like I was saying, odd numbers just don't feel reasonable to me, especially doing like 8 divided by 5. Just, I know that's not going to produce a whole number. It's going to produce like something with a decimal attached to it. It just doesn't feel like a number that I would plug in. So the next one I would try is 4. And then here we can see that doing 4 over 2 gives us 2. And then 8 over 4 gives us another 2. And that's the 4 that we want on this side of the equation. And so it's this 4 actually that was the x value that I plugged in and matched today's date. Now, guessing and checking worked pretty well here. I kind of like figured out where my upper and lower bounds were. I figured out what like a reasonable number to try would be. But I also want to show like how you could directly solve for this instead of trying to guess and check. In previous videos, I've mentioned how whenever you have fractions and you're like able to find a common denominator, usually that's a good strategy. Or another good strategy is to just get rid of the fractions entirely. So trying to find some kind of common denominator, I'm noticing if I multiply each of my terms by, it looks like 2x, I will just remove all of the fractions in this problem. So if I multiply the top and bottom of all three of these things by 2x, I'm not changing the value of anything. I'm just making it look a little different. And actually, you know what? Why not? I don't need to multiply this 4 by 2x. Or maybe I do. Yeah, I was deciding between two different strategies. One of them is to just multiply by basically the number 1. When you have the same thing on the top and bottom of a fraction, it's essentially the number 1, and you're not changing the value of your other fraction, this one. But another strategy is to do an algebra step, which would be to actually change the values of what you're working with, but change them by the same amount. So if I multiply both sides of my equation by 2x, I'm not going to change the equality. as in these two things will still be equal to each other, but I'm actually changing their values this time. So distributing this 2x into here, this 2 in right here and the 2 in the denominator cancel. And so I'm just left with an x squared. Then these x's cancel right here, and so I'm left with a 16 once I distribute this 2x into both of those terms. And then this should be equal to 8x on the right side of the equation. And I have a quadratic equation, so for these ones, I really like setting everything equal to 0. So if I subtract 8x from both sides, I'm able to produce a 0 on the right. And we have something here called a perfect square trinomial. I recognize these patterns because I've done a lot of work with quadratics. I know that doing x minus 4 squared produces this on top. Maybe I could convince you with an area model. Doing x minus 4 squared is just like saying, well, make a square out of an x and a minus 4. And if you wanted to find an alternate value for x minus 4 squared, you can do all of these little mini multiplication problems. And it's kind of like I'm finding the area of this big rectangle by adding up all the areas of these small rectangles. And so x minus 4 times x minus 4 produces the area of the big rectangle. And then adding up an x squared, oops, not that one, I wanted to circle this one. Adding up an x squared, subtracting away an 8x, and then finally adding a 16 is just the same thing. So these two expressions are the same, and you could go between each form, whichever one you want. This time, I just want the factored form, or the one where stuff is being multiplied to each other. Because I know that when I have something squared is 0, well, there's only one number out there where when you multiply it by itself, you get 0. It's 0. 0 times 0 is 0. So that means that x minus 4 has to be 0. So x has to be 4. And this algebraic way of solving it with variables and, doing this like solving for x process is really useful because now I know there are no other values of x that could satisfy this equation. Like maybe there would have been another one. Just by guessing and checking, I checked only 3 numbers. I know that 8 doesn't work, 6 doesn't work, and 4 works, but that says nothing about plugging in a 2 or a 1 or a 1 million. So going through the algebra steps and only coming across one solution is just that much more confidence that the answer is 4 and it's only 4. So thanks for walking through these 2 different solutions with me. And I'll see you tomorrow. Alrighty, bye-bye.